Hello, Integrated Math 3 and Integrated Math 3 Plus. Welcome to lesson 16-2. We're going to be continuing our discussion of trigonometric functions, specifically sine and cosine. We'll get into others in a bit, but we'll start with sine and cosine to kind of start this party off right. So we talked about special right triangles, 45, 45, 90, 30, 60, 90. We used them a little bit in the last lesson, but what really started all of this was sine, cosine, and tangent. And we saw this on an earlier, and the last lesson on an earlier slide. Of course, sine of an angle A is the opposite leg, that's the leg across from it, over the hypotenuse. And the hypotenuse is always, 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 and I'm going to grab my pen, always, always, always the side that is across from the right angle on your right triangle. And we use that to find angles and to find sides and other things. We're like, okay, well, the sine is the opposite leg over the hypotenuse. The cosine of angle A would be the adjacent leg, the leg next to it, over the hypotenuse. And of course, the tangent of angle A would be the adjacent, the ratio of the opposite leg over the adjacent leg. So what do these ratios have to do with how we finished off last time? Last time we were finding the x-coordinates and the y-coordinates of point P on our unit circle. There's a relationship here with sine and cosine. So let's talk about how these relationships happen. So we use special right triangles and a reference triangle to find the y-coordinate of the intersection of the terminal side of a 135-degree angle and the unit circle. We did that last time. And you're going to see that these right triangle trigonometric ratios with reference triangles as well will help you find sine, cosine, tangent, all that good stuff. So what I would like you to do is just start things basic. I would like you to grab your calculator. And I would like you to use your calculator, just plunk it in the calculator on number 10 there, and find what is the sine of 60 degrees, the sine of 30 degrees, and the sine of 135 degrees. Just write down each one of those and then kind of compare it with our P coordinates that we were finding on the last lesson. So go ahead and hit pause to grab a calculator and work those out, and then hit play when you're ready to check your work. So real quick, I grabbed my calculator because that's what calculators are for. Grab my calculator and I did each of these and I was like, okay, oops, getting carried away. I was writing already. I wasn't ready to write yet. So here we go. So I did the sine of 60 degrees and I used my calculator to help me do that. Make sure your calculator's in degrees if this doesn't work well. And I got about 0.866. That number should look familiar to us from last time. If I do the sine of 30 degrees, again, I'm going to use my calculator to help me out with that. So if I do 0.5 and I do the sine, or try that again, 30 degrees and I do the sine, I get 0.5. Oh my gosh, I can't even write things down right. Oh, and that's exact. That's not even approximate. That's exact. And then, of course, last but not least, I'm going to do the sine of 135 degrees. And that's what I have the calculator for. So 135, find the sine, and I get, again, this should look familiar, 0.707. If you look back at your notes from the last lesson, these numbers are going to look really, really familiar to you. Because guess what, guys? These were your y coordinates. Oh, yes, they were. Why? Let's find out. So let's talk about that. Hopefully you caught this. So you were set to degrees and you found the sine of each angle, and what you discovered was that these are actually the y coordinates for P for those last examples we were doing on the last lesson. So why is that happening? That's the big question here, right? The deal is this. Remember how we said that when you find the sine of an angle, and we're going to call that angle alpha just to make things a little easier for us. So that's that little fish-looking guy. That's a little baby alpha, a little lowercase alpha. Thank you, Greek alphabet. So for any angle alpha, remember that sine was the opposite leg over the hypotenuse. But on a unit circle, my hypotenuse is always 1. And the opposite is always my y coordinate. So the sine of alpha is always going to be my y coordinate divided by 1. Which is just y, which is why the sine of the angle kept giving me my y coordinate. That also means, though, by the way, that the cosine of alpha, remember that we just said that cosine was the adjacent leg of the hypotenuse, and here we can see the adjacent leg is x, my x coordinate, and my hypotenuse, because it's a unit circle, is of course 1. So x divided by 1, well, that just gives me x. That's why this is happening, that when you do the sine of an angle, you're finding the y coordinate of a point on the unit circle. And when you do the cosine of an angle, you're finding the x coordinate of a point on a unit circle. Now, unit circles are unit circles because the radius was always 1. But of course, it could actually work for any circle. So you could say that the sine of angle alpha is your y coordinate divided by whatever your radius is. It was just easy on the unit circle because the unit circle had a radius of 1. Same thing with cosine, that the cosine of alpha, so work for any circle, equals the x coordinate divided by the radius of the circle. And again, it was just super easy on a unit circle because my radius is 1. So where x and y are the coordinates of the points of intersection on the circle. So that's actually a really cool trick. And using this trick, here's what I would like you to do. I would like you to use this idea that the sine of an angle is its y coordinate and the cosine of an angle is its x coordinate. And I would like you to go over to question number 11. Since we already did 10, we're on student activity sheet number 2. You already did question number 10. I'd like you to do question number 11. Go ahead and hit pause to work these out. Give me points for my coordinates. Give me the coordinates for my points, that too. And then hit play when you're ready to check your work. All right, people, how'd you do? So I did the sine of 45 degrees and the cosine of 45 degrees. The cosine of 45 degrees gives me the x-coordinate for my point, and the sine of 45 degrees gives me the y-coordinate for my point. So I did that. Cosine gives me the x-coordinate, sine gives me the y-coordinate. Yay, there they are. You had to be a little more careful with the others, and I'll show you why in just a moment. Let me grab my pen and I can show you why. 160 degrees, again, cosine gives me the x-coordinate, sine gives me the y-coordinate. Yay. And again, cosine gives me the x-coordinate, sine gives me the y-coordinate for 220 degrees. And same thing with 335. Cosine gives me the x-coordinate, sine gives me the y-coordinate. Now, why are some of these negative and some of these positive? Can we talk about that for just a minute? Can we talk about that? Hey, 45 degrees is in the x, and this is in the first quadrant. So my x is positive. My x goes right, it's positive. My y goes up, it's positive. But when I do 160 degrees, that's more than 90, but less than 80. So I'm out here somewhere, which means, yeah, my y coordinate's still positive because I'm going up, but my x coordinate's going left, which means it's negative. And yeah, that explains what was going on with these others. 220, so that's 0, 90, 180, ooh, not quite to 270. So we're going to stick that out there, which means both my x-coordinate and y-coordinate are negative. I'm going left, I'm going down. And if we look at this last guy, 335, so 0, 90, 180, 270, but not quite to 360. So it's out here somewhere, which means my x-coordinate, I'm going right, so that's positive, but my y-coordinate is going down, so that's negative. So that's why we're getting negatives on some of these. And your calculator may have been taking care of that for you, as it should have. Good job, little calculator. All right. Now that you're feeling like you've mastered number 11, you got the idea on this. Let's go ahead and pop on over and keep this party going. Questions 12 all the way through 16. We got a lot going on this page. We have a lot going on this page. So stick with me, people, and we are going to get this job done. Now, we said the unit circle, our hypotenuse is always 1. Because a unit circle always has a radius of 1. That's what makes it a unit circle, which means my hypotenuse is always a positive 1. Golly, it just makes life so much easier because dividing by 1 and multiplying by 1 and doing stuff with a 1 just makes life easier. It just makes things convenient when we're dealing with our trig ratios so that I can say, yeah, the sine of the angle is my y-coordinate, the cosine of the angle is my x-coordinate. So it makes life a little bit easier for all of us. Now, as a point moves around the unit circle, of course, the x and y coordinates are determined by our angle of rotation, right? As my angle gets bigger and smaller and starts moving around, that moves my point, and of course, that's going to change my x coordinates and my y coordinates. So, stick with me. let's start off by playing with sine. Let's talk about how as this moves around and around and around, my y-coordinate is changing. Now, of course, the y-coordinate here is the height. So can we play with that just a little bit? Play with that just a little bit. Of course, I got to get my little guy to do what I want him to do. It'll do it. I know it will. There we go. There's my button. So let's play with this. As you can see, as I'm turning around and around and around, we're on number 12, by the way, if you're not sure where we went on your student activity sheet, but my y-coordinate gets smaller, negative, smaller, 0, bigger, bigger. Yeah. So you can see that my y-coordinate keeps changing as we go. We're going to explore that a little bit more. So here's the deal. We're going to start here and work our way around. So like we said, once I get past 180, my y-coordinate's negative, and there we go. So we start at 0, right? From the beginning, I have no y-coordinate. If I start at the very beginning, if I have an angle of 0 degrees, I have no y-coordinate. But as I move up, my y-coordinate gets bigger and bigger and bigger all the way until it gets to 1, and then it gets smaller and smaller and smaller back to 0 again. You can see it right here at 180 degrees. Then, of course, once I go below that, well, suddenly I'm going down instead of up. So my y-coordinate became negative, bigger, 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 bigger until it gets to -1 and then shrinks back down to 0 again once I've gone all the way back around to 360 degrees. So you can see what's going on with my y-coordinate here, which was, of course, the whole point of this. And that is that my y-coordinate is going all the way up to 1 and all the way down to -1 and everything in between. By the way, I hope this is helping you sketch your graph on question number 12. In fact, let's go further, right? Because I have more here. Let's keep spinning around. So it gets bigger to 1, shrinks down to 0, down to -1, shrinks back to 0. Oh, it repeated itself. Look at that. So it looks like after 360 degrees, it repeated itself again. Yeah, guys, this is a periodic function. Oh my goodness. Yeah, this is totally a periodic function. Most definitely. Most definitely. So can we, now that you have your graph for number 12, can we take this further and find the answers to question number 13? You can even use your graph to do it. I want the sine of 0 degrees, 90 degrees, when we have 180 degrees, and 270 degrees. So I would like you to answer those questions there on number 13. Go ahead and hit pause to work this out, and then hit play when you're ready to check your work. So see how you did. I think you did okay. So at 0 degrees, my y-coordinate is 0, and my radius is 1. So 0 divided by 1 means at 0 degrees, it's 0. Hey. That means as I go up to 90 degrees, my y-coordinate is 1. My radius is 1. So 1 divided by 1 is 1. Sine of 90 degrees is 1. If I go over to 180 degrees, my y-coordinate is 0 again. And my radius is 1. Boom, stick those in there. 0 divided by 1 is, of course, 0. And if I keep going to 270 degrees, my y-coordinate is 1. Or actually, take that back. My y-coordinate is -1. Divided by a radius of 1. Well, -1 divided by 1 is -1. Yay. So it's interesting because when I use 0 degrees, 90 degrees, 180 degrees, and 270 degrees, that gives me my y-intercepts at 0 and at 180, but it also gives me my maximum at 90 and my minimum at 270. So it goes all the way up to 1, all the way down to -1. So these are kind of important angles to know, 0, 90, 180, and 270, because they give you x-intercepts and they give you maximums and minimums as far as your sine goes. Here's your sine. All right, people. Have you been having fun playing with sine? I hope so. Let's go to cosine. Cosine. Now, cosine's a little different because we're taking the x-coordinate now, right? So watch out. This is now the x-coordinate that we're using. Yeah, And we're going to do 1 full rotation. So notice that we're now using the x coordinate, okay? Remember we said that cosine was our x coordinate. So to begin with, my x coordinate is 1, right? So there it is, my x coordinate is 1. As we move, my x coordinate gets smaller and smaller. As we get to 90 degrees, I have no x coordinate left. As I move past that, my x coordinate goes negative until I get all the way out here to -1 at 180 degrees. And then, of course, my x coordinate negative, negative, negative till I get back to 0 at 270. And then my x coordinate gets bigger and bigger and bigger and bigger as we come back out here, back to 1. Oh, we'll keep it going. Why not? What if I do another rotation? Ooh, so pretty. I love the purple. Guys, it's periodic function. Yeah, because check it out. I did 1 full rotation, and after 360 degrees, I started to repeat myself all over again. That's right. Cosine is a periodic function. I bet you're not shocked by that. And I hope you got that graph down on number 14, because it's probably going to help you answer question number 15, where you have to tell me the cosine of 0 degrees, cosine of 90 degrees, the cosine of 180 degrees, and the cosine of 270. So go ahead and hit pause to work out number 15, and then hit play when you're ready to check your work. How you doing? You doing good? So remember cosine was the x-coordinate over the radius, so 1 divided by 1, which is 1. For the cosine of 90 degrees, I have no x-coordinate, so it's 0 divided by my radius of 1. 0 divided by 1 is, of course, well, 0. Yay. Cosine of 180 degrees, let's go a little further, boom, and my x-coordinate is now a -1 divided by 1, which gives me a -1. And if I want to find the cosine of 270 degrees, I lost my x-coordinate again. It's down to 0 divided by my radius, which is 1. 0 divided by 1 is, well, 0. Yay. All right, that's a beautiful, lovely thing. Sweet. So that helps you out with question 15. Now, here's the big question to bring it all together to finish this off. Question number 16. You now have a graph for y equals cosine alpha, and you already had a graph for y equals sine alpha. How are these bad boys related to each other? Hit pause to give some thought into that and take a look and compare a little bit, and then hit play when you're ready to check your work. I apologize for my neighbor using the leaf blower, but hopefully you notice something, that these two curves are the same. They're just off by about 90 degrees. It's a 90-degree horizontal shift. So a great way to write this is to say, hey, the sine of alpha is equal to the cosine of alpha minus 90 degrees. It's a 90-degree shift to the right. You guys know a shift to the right means it goes inside, and it's always x minus whatever it is that we're shifting to the right. Come on. So sine of alpha is actually equal to the cosine of alpha minus 90. Oh yeah, they're both sinusoidal waves. Maybe that's why they're called sine and cosine, because they're only off by like 90. Otherwise, they're the same. Ooh, hope you enjoyed that deep thought for the day. And on that note, I hope you found this helpful, and I hope you found this useful. If you got questions or concerns, email me or come see me during office hours. And I'll see you soon. Bye.